All right, we are live. Welcome, everybody. I'm very excited to be here. I'm very excited to have the guests that I do, the guest and moderator that I do. So for those of you that don't know, which would be weird if you were here and didn't know what this is, but my name is Dan. My channel is Creation Myths, and it's all about debunking creationism. So my opponent tonight for this debate is Standing for Truth, who needs no introduction, but Standing, why don't you take a second to introduce yourself, and then we'll get into the format.
Awesome. Well, thanks for having me on this program tonight there, Dr. Dan. Thanks for being timekeeper, Dakota. Yeah, I'm looking forward to this. This is one of my favorite topics to discuss, human evolution, Neanderthals, for example. So yeah, I'm really excited to be here tonight. That's really all I've got to say.
Great. So just to give everybody a little bit of background here, so I posted a video last week about how Neanderthals are the creation myth, that Neanderthals are descended from Homo sapiens. They are not. And by the way, I can hear the face that some people are making right now. If you are looking for fake objectivity, because this is a debate, you will not find it here. You don't know me well enough. But basically, I put up this video and Standing reached out to talk about it. So here we are. We're going to talk about whether Neanderthals are descended from Homo sapiens. So the way this will work is we're going to do very brief opening arguments, about 5 minutes. So Standing is going to go first, then I'll go, then we'll have just an open discussion, keeping it to 90 seconds each as we go back and forth. We'll finish with brief closings, and then we'll do a Q&A. If you have any questions throughout, just tag Deadly Dakota Raptor in the chat. So Deadly, if you could just say hi for everybody. By the way, thank you to Deadly Dakota Raptor for being here and being our timekeeper and question curator. And yeah, there are no super chats, so just tag Dakota, and that'll allow us to keep the questions straight. We're looking at no more than 90 minutes here. We figure openings, closings, plus discussion about an hour, and then we'll see how many questions there are, and 20 to 30 minutes. We'll see. So that's what we're going to do. So Standing, over to you. Kick us off.
Awesome. Thanks again. Yeah, I think judging by the audience, we should have some good questions for the Q&A. So I'm sure this is going to fly by. Let me just get myself settled here before we start the timer. I'll share anybody
And while you're getting ready, if anybody notices...
Won't be much of a huge rebuttal.
While you're getting ready, if anybody notices any tech problems as far as things not working, just shout out in the chat so we catch it as soon as possible. Thank you. All right, let's pull these slides up here.
Okay, so at this point, I am good to go whenever you are ready there, Dr. Dan.
Let's do that. You are set.
Okay, perfect. So yeah, just Dakota, give me when I reach the 5-minute mark, just let me know, and then I'll start winding down. But it should be more than enough. So I will start now. Thanks again. Thanks so much. So debate with Dr. Dan Stern-Cardinal on Neanderthals. So bones of Neanderthal were first discovered in the Neander Valley, located in Germany in 1856. This is where we get the name Neanderthal. Nearly 500 Neanderthal skeletons have been found. Debates have raged to this day between paleo experts on whether or not Neanderthal should be classified as Homo sapiens or a separate species altogether. This is an aspect of what we are here today to discuss. Upon their first discovery, Neanderthals were depicted as inhuman and brutish cavemen, when in fact we now know that Neanderthals were quite advanced and no less human than anybody here today. According to the story of human evolution, Homo neanderthalensis is our closest ancestor on the human family tree. They are said to have survived a cold glacial ecosystem. Experts in human evolution have suggested that these cold and harsh environments would have influenced the Neanderthals' physique. Their bodies were relatively short. They are described as being incredibly robust and well adapted to various environmental conditions, which would be consistent with a post-flood, post-Babel world. They are also described with broad chests, bulky torsos, and muscular limbs. The adaptations seen in Neanderthals helped to generate and retain body heat. Neanderthals had large noses and strong brow ridges. They also had large brains similar in size to modern humans. Archaeological evidence suggests that Neanderthals had a relatively sophisticated culture. This, of course, speaks to intelligence. They also lived alongside anatomically modern humans and were even interfertile and interbred. We see Neanderthal genes in modern populations. It is 100% clear that Neanderthals were fully human and a lot like modern humans. The evidence for gene flow between Homo sapiens and Neanderthals is compelling. Lumpers have argued that Neanderthals should be classified as Homo sapiens or Homo sapiens subspecies Neanderthalensis, but not as separate species, as I believe Dan here today purports. We find the classic Neanderthal characteristics and features in living people today. If the skull cap of this boxer right here, for example, were discovered as an isolated bone, it is almost certain that a splitter would identify him as a separate species, when in fact that would be totally wrong. There have been bone pits discovered actually that show incredible human variation in skulls. This includes numerous features associated with Homo sapiens, Erectus, Heidelbergensis, and Neanderthals. Many paleo experts have suggested that these are not all separate species, but represent the same interbreeding species. Now, I know what you are going to say. Sure, Neanderthals had incredible, sophisticated cultural skills and evidence for spirituality and appeared human in every way. But the question is, did they meme? And I say good point. And here's just a few of my favorite memes, of course. Okay, the humor out of the way. When it comes to the hominin fossil record, I have very often pointed out that there are a couple different things going on that would give experts in human evolution the notion that various bones are transitional. One is that there are often artificial species that consist of a mixture of ape and human beings. It is not uncommon that bones of multiple species have been confused as one single species. These species, of course, being humans and apes. These species are being found together at these sites. The bones are intermingled. The other major issue that I believe we will be discussing a bit here today has to do with the many claimed transitional bones that all show pathology consistent with small inbred tribes post-Babel. This is a common theme found in the fossil record. There has been a recent paper here that actually corroborates this claim. The author of this paper points out that oftentimes these bones that are found to be old are also riddled with pathology and disease. The paper also points out the fact that this pathology cannot be due to chance. There is just too much. The people that are looking for intermediate forms will typically pick up the unique bones. These are the atypical bones they hope are evidence for the ape to man story. We know these bones are the result of rapid and tropic decay. Almost done here. What is the Neanderthal? That's what we're here to discuss. Well, the genetic data suggests that Neanderthals had a lot of mutations due to inbreeding and isolation. They were seriously inbred. They would have branched away at Babel or possibly even before and spread out widely. They all show serious evidence of inbreeding. This means that all the mutations that have been accumulated are manifested. Whenever there is inbreeding, we find pathology consistent with the Babel dispersion. The hominin fossil record is simply evidence of rapid genetic degeneration, which is why we find skeletal pathology. We find reduced body sizes, reduced brain sizes, etc. Neanderthal appears to have been just one of the few people groups that suffered from inbreeding and pathology. I'll leave the responses and rebuttals to Dr. Dan's points after I see which ones he may bring forth in his opening. So I appreciate the time here for an introduction, and thank you so much.
Right on time.
Beautiful. Thank you. All right. So let me just pull up my thing here. This will just take a second. Here we go. That's the one. That's the one. Okay, let's put that there. Great. Now, here's the $1 million question. Is it going to go? I think it goes. How did that look, Dakota and standing? I think it switched. So
looks good to me. I can see it at least.
I think it worked. Okay. So what I'm going to do is just keep an eye on this and make sure everything's good. Okay. So here is, okay, so I'm going to go. Ready? 3, 2, 1. Here we go. So let me start by saying that I apologize for anyone who was coming here looking to hear a discussion about bones, but I'm going to say precisely nothing about skeletons or anything else in that regard. No bones, no morphology, no pathologies, none of that stuff. The case that I'm going to make is purely based on genetics because conveniently we have full Neanderthal genomes, we have Neanderthal mitochondrial genomes. We don't need to talk about bones at all to establish whether or not Neanderthals are descended from Homo sapiens. So the creationist argument is that Neanderthals are human, they're Homo sapiens, and they are in the creation model descended from Adam and Eve. So you can see this right here in the Answers Research Journal from Answers in Genesis. You can see that right here in the second headline from Creation Research Institute. They're saying Neanderthals, they're us. They are Homo sapiens. Now, there we go. This is great. I really like a specific claim like this because it leads to testable predictions. Because again, we have the genome, so we can compare them. The creation model, the young Earth creation model, requires that Neanderthals are nested within the Homo sapiens clade. By the way, I just want to check, are my slides switching? I think they are. I think we're okay. So the Neanderthals need to be nested within the Homo sapiens clade. In this first phylogeny here, the root at the top middle of the tree represents Adam and Eve, according to creationists. Everything in blue is Homo sapiens, and then the red branch represents the Neanderthals descended from Homo sapiens. And in fact, Neanderthals are Homo sapiens. This is what evolution says, is that Neanderthals are the sister group to Homo sapiens. They share a common ancestor, but that common ancestor was neither Neanderthal nor Homo sapien. So again, these are the two predictions, and we can actually evaluate the genetic data and see which one is correct. So there are problems with the creation model in this regard. The first problem is that Neanderthals are unequivocally the sister group to, not part of, the Homo sapiens clade. And you can see in this figure, which is from a textbook by Zimmer and Emlyn, 2016, you can see the blue regions, that's the Homo sapiens clade, and then the sister group to that in red, that's the Neanderthal clade. That common ancestor that's indicated by the arrow, that is not Homo sapiens. That's, again, not ambiguous based on these data, so the creationist prediction is incorrect. The second problem is that Neanderthals break the creationist most recent common ancestor dates. Young Earth creationists require a most recent common ancestor to conform with young Earth timelines. For example, Nathaniel Jeanson, 2015, talking about mitochondrial Eve for Answers in Genesis. Now, this is already wrong without Neanderthals. Standing, we've talked about this before, and you've indicated you don't want to talk about why Jeanson is wrong about any of this stuff anymore. But like the actual age for this stuff is the Homo sapien mitochondrial most recent common ancestor is 60 to 200,000 years ago, not 6,000. But for our discussion tonight, that doesn't matter. Let's pretend that that ancestor is actually 6,000 years ago. The problem for creationists is that given how different Neanderthals are, if you add them into it, you get a new most recent common ancestor that is too far in the distant past to adhere to young Earth timelines. So in effect, we have two predictions here that must be true for creationists, but are contradictory with each other. One is a young, most recent common ancestor for Homo sapiens, and two is that Neanderthals are Homo sapiens. Those two things are incompatible. Now, the creationist response to this that I've heard most commonly is that Neanderthals were hypermutating. They have faster mutation rates than the rest of Homo sapiens, and that explains what's going on. There are a couple problems with this. The first one is that it's contradicted just by the direct evidence that we have. We have Neanderthal genomes. We know what they looked like, and we know, as Standing said, they were inbred. If they were hypermutating, we'd see lots of genetic diversity, not a very narrow band of genetic diversity due to inbreeding. Okay, so we just know they weren't hypermutating. But even if we assume they were, that doesn't solve the nesting problem. What you would see if they were hypermutating is what this tree shows. You would see the Neanderthal branch still falling within the Homo sapiens clade, but it would have longer branches, indicating more mutations in that one subgroup compared to the rest of the tree. So the revised creationist prediction, still wrong. So to summarize, many young Earth creationists claim that Neanderthals are descended from Homo sapiens. They descended from Adam and Eve. This is perfectly rational. It's actually required for the young Earth model. But this is contradicted by all available genetic data. Neanderthals are the sister group to Homo sapiens, not nested within the Homo sapiens clade. Neanderthals being Homo sapiens violates the young Earth most recent common ancestor timelines. There's just too much diversity to account for in 6,000 years. And as for the revision that they're hypermutating, we have their genomes. They had less diversity than you would expect, not more. They were inbred. So we just know that that's wrong. And even if it wasn't, it still doesn't work with the data that we have. So if creationists want to claim that Neanderthals are descended from Adam and Eve, you have to show why all of this data that shows otherwise specifically is wrong. And with that, I'll turn it back over. Thank you all. Standing, back to you. Take your best shot.
We're gonna 90 seconds. I'm gonna give them a warning at 15 seconds.
Thank
I
you.
appreciate it. I appreciate
There we go.
I appreciate that that opening there, Dan. I think there's a lot that we can discuss here that I'm excited to discuss. For this first 90-second response, I won't share screen. I'll just kind of start off with some common ground. Actually, one thing that did come to mind that I find fascinating is it just so happens humans have exactly the same chromosome numbers as Neanderthal, and the fact that we can mate with them speaks of course, their humanity as being one species. But one thing that I want to get out of the way is Dr. Nathaniel Jeanson, as Dr. Dan talked about regarding the Neanderthals. He has two competing explanations. Hypermutating and possibly the DNA extracted from Neanderthals is too degraded to be reliable. Now, to get some common ground, I do hold to the hypermutating hypothesis, because the fact is, I agree with Dan probably that the Neanderthal DNA that we have really is Neanderthal DNA and not somehow damaged or messed up. And how we know this, that it's not just been sitting around in the ground, and we know that it's chemically damaged, is because the fact that the DNA samples themselves are so consistent. We see consistency in the DNA. So if we actually were looking at randomness, I personally would not expect the DNA to be so consistent. For example, we would have, let's look at the expectations we would have. If we have Neanderthal DNA from, say, Spain and Neanderthal DNA from Siberia, would we expect it to be as consistent versus just random errors? So I think the fact that we see it so consistent, we are looking at reliable Neanderthal DNA, just to get that part out of the way. And we'll see if Dr. Dan agrees with that. So thanks for the 15-second warning.
Yeah, 100% agree. The consistency completely undermines the degradation argument. If they were degraded, they'd be divergent, but they're consistent, so we know it's not just degraded. So yeah, we totally agree on that. So I think the first place where we disagree is on the phylogeny. So the first thing I want to establish is, do we agree on what the phylogeny should look like if Neanderthals were descended from Adam and Eve, right? So do we agree that we would have a common ancestor, a lot of Homo sapiens, and somewhere in there we'd have Neanderthals? Can we agree on that?
I would agree that the phylogeny, are you saying the phylogeny according to the biblical base model versus the evolutionary model?
Saying the phylogeny predicted by the young Earth model regarding Neanderthals being descendants from Adam and Eve.
Yes, I would agree. Yeah, I've got some pictures I can screen share to show why I believe that phylogeny is consistent. But yeah, I would agree, yes.
Well, okay, so, but what I'm asking about is the prediction. Do we agree that the prediction is what I showed, that it's Neanderthals nested within the Homo sapiens clade?
Because it's been thousands of years of genetic change in humans since the extinction of the Neanderthals, I would expect some differences enough in the Neanderthal to the point where they may, well, we know Neanderthals are 99.7% similar to humans, while all humans today are 99.999% similar. So you pointing out that they're a sister group and that they fall a little bit outside the modern human group, I would agree with that, yes.
Okay, so you accept that so I'm going to pull up a couple of phylogenies here, because this is the crux of the matter, right? Is it that the Neanderthals are like part of Homo sapien, part of the Homo sapiens clade, or are they a separate clade that shares a common ancestor with Homo sapiens? That is the question. So what I want to just show you here is just a couple of phylogenies. I'm going to just share that PowerPoint again. There we go. Here we go. Okay, so let me just scroll down to here. Here we have a bunch of phylogenies, a bunch of papers. They all show the same thing. What they all show is that you have a common ancestor that is not Neanderthal, and it's not Homo sapien. So those three trees on the left, that's mitochondrial, Y chromosome, and full genome trees for Neanderthals and humans, and also Denisovans. And what the question is what is that common ancestor? And the answer is that it's not Homo sapiens and it's not Neanderthals. That's the central disagreement here, because correct me if I'm wrong, according to the creation model, whether the Neanderthals fall out as kind of a side branch or a branch way down in the middle, that common ancestor in the creation model has to be Adam and Eve, right?
Oops. Okay. Was that the end of your 90 seconds? I'm just going to screen.
Yeah.
Awesome. I'm just going to screen share real quick. Maybe don't start the 90 seconds just till I make sure that it's being shown. So I guess while that's those slides are coming up. Okay, so we have genes that are inherited from Neanderthal ancestors, and the form of the Neanderthal, their development, their DNA itself, since we're kind of focusing on genetics, may be considered very slightly out of the range of what we find today in modern humans and the modern world, yes. But nevertheless, the whole massive amount of evidence we have with, for example, a lot of the examples I showed in my opening with their tool use, their fire use, their hunting, the way they treated their dead bodies, including burying their dead, for example, and also showing evidence for spirituality, all confirms the humanity of Neanderthals. And a lot of lumpers, even in the world of paleontology, agree that they are one species and not separate species. My disagreement is the prediction that they should have more genetic diversity than modern humans, because as you can see here, by inbreeding, individuals are further decreasing genetic variation by increasing homozygosity in the genomes of their offspring. Thus, the likelihood of deleterious recessive alleles to pair is significantly higher in a small inbreeding population than in a larger inbreeding population. So the point is, the fact that we know that the Neanderthals were highly inbred and they existed in small tribes, we would actually expect lower genetic variation, since by definition, these mutations are manifested and they erode genetic variation. So I don't know why that prediction would be expected on your side when exactly what we would predict is exactly what we see. Was that time you said?
I said 15.
15 seconds? Yeah. So my point is, from all the sources that I have here, and just by definition, what inbreeding does, it reveals the hidden reservoir of genetic mistakes that would erode genetic variation. So I don't understand. I don't really agree with that prediction. Go ahead, Dan.
So the reason it matters is that the way evolution, the way phylogenetics works, is that it is based on common ancestry. So it's funny because the tables are kind of turned here. Normally, it's the evolutionary biologists that are making the claim that X and Y share common ancestry, right? And characterizing exactly what that thing is. But in this case, it's the other way around. In this case, I'm arguing that, well, we have common ancestry between Neanderthals and Homo sapiens, but it's not Homo sapiens. And this is again, I'm gonna pull up this slide here.
Okay, here,
add this one. I'm gonna show this as a full screen here. You can look at all these different trees. Oh, that broke it. I'm bad at this, everybody. Let's try that again without breaking it this time. Huh? There we go. Now we're good. Okay, so you can look at this. This is a phylogeny from 2014. It's mitochondrial DNA. In the bottom, you've got your Homo sapiens, and then up in top in green and blue, you've got Neanderthals and Denisovans. And we don't even have to talk about Denisovans today, but that creates even more of the problems that I've already talked about. So the disagreement is about the node between the Neanderthals and the Homo sapiens. In the creation model, that has to be Adam and Eve, right? It doesn't matter where the Neanderthals fall out in the tree, but the node, that is that most recent common ancestor, which is the junction point here. I don't think you can see my cursor, but it's the junction point. If you follow the Homo sapiens lineage back and the Neanderthal lineage back, it's where the horizontal line in the middle of that vertical line goes to the left between the two of them, right? That junction point, that's the node, that's the most recent common ancestor of those two things. And in the creation model, that has to be Adam and Eve, right? Is that wrong?
My starting point when it comes to, well, here, are we going to restart the 90 seconds? Because I just want to share screen too.
Yeah, here you go. We'll switch over. Where's your screen? I don't see anything coming up.
Actually, okay. So as I'm sharing, one clarifying question, if we could, before we start the 90 seconds, because I don't want to misrepresent your position.
Yeah.
You have them as an outgroup, as a sister group, because of their differences to modern people. For example, they have, like, they're 99.7% similar to modern humans, while we are all 99.999% similar. So we have them.
That's not how we
can
figure
you
out they're the sister group. We know they're the sister group based on not the quantity of differences between them, but the specific differences, right? So we can look at specific genetic markers that are found in Neanderthals, but not any Homo sapiens. We can look at markers in Homo sapiens that are absent from Neanderthals. And the absence...
Right. Okay.
The absence of those two things indicates that they are separate clades that share a common ancestor in the more distant past than the common ancestor for either of those clades on their own.
Okay. Okay. So if my 90 seconds could start here, yeah, I think I see what you're saying. So first point I want to make is I just want to also reiterate the fact that for us to expect more genetic diversity in Neanderthals versus modern humans, I don't believe is a valid objection or prediction, since we know that genetic diversity will be decreased and eroded due to inbreeding. And we know that they were highly inbred. Therefore, that is exactly what we would predict, and that's exactly what we see. There's a new paper actually that came out that says humans and Neanderthals less different than polar bears and brown bears. And I'm not the only one that's agreeing that Homo neanderthalensis and Homo sapiens are the same species. For example, I've got plenty of technical papers, and I've watched plenty of lectures that say that modern humans, the fact that they interbred with Neanderthals, I think it comes down to the definition of species at this point, but plenty of paleo experts that would be considered lumpers, you got splitters and you got lumpers, they lump Neanderthalensis, Erectus, the hobbits, Homo sapiens in the same species. Now, they might consider them a subspecies, right? Homo sapiens, subspecies, Homo neanderthalensis, rather than a separate species. But it seems to me that you are purporting that they are a separate species altogether. Is that your position, that they are just a totally separate species? They're not even a subspecies of modern humans? I imagine. So I'll end it with that question. Are you purporting that they're a totally separate species rather than just a subspecies of modern Homo sapiens? Go ahead.
Yeah, absolutely. I should start by saying that I think species concepts are dumb and make it harder to understand things, not easier. And I think we should be talking about, and I say we, I mean biology in general, should concern itself with ancestry and not putting things in arbitrary boxes. But if you're going to make Neanderthals and Homo sapiens the same species, then it is a polyphyletic group. It's a group that doesn't share a common ancestor, that's a member of that group. So that common ancestor is not Homo sapiens and it's not Neanderthals. So just to address a couple quick points, I'm not saying they're more diverse. I'm saying they're different. Those are two different things. Them being a sister group does not mean they're more diverse than humans. It means they exhibit a different set of biodiversity compared to Homo sapiens. Okay, that's the thing. It's not that they're more diverse. It's that they are different, and we can quantify and characterize those differences. This is also not about splitters and lumpers. This is not about which species definition we use. Do we use the high school biological species definition, or do we use a more modern definition of species? It's not about that. It's about common ancestry and characterizing the time and the nature of the common ancestors. And genetically,
15 seconds.
Thank you. We can look at Neanderthal DNA. We can look at Homo sapiens. And we know that that common ancestor was not Homo sapiens, which means it is not Adam and Eve, which means the young Earth model is wrong on this question.
Okay, so since I got 90 seconds, I'm going to talk fast here. Of course, we would find different genetic markers. Of course, we would find different genetic differences, since Neanderthals were highly inbred, they accumulated a high genetic load, and they've been extinct for thousands of years. Therefore, modern humans have been accumulating new genetic differences. They've been accumulating new genetic markers, new alleles through mutation. So, of course, there's going to be some differences. But Neanderthals are 99.7% similar to humans. Combined with everything else that I showed that's not genetic related, I think it's, to be honest with you, I don't think it's scientific to say that they're different species. I think the lumpers versus the splitters, which you say is not a factor, but the fact is there are paleo experts that say, hey, listen, they're the same species. That obviously disagrees with your position here. How many seconds do I have? Because I have a question that I want to ask real quick for him to.
45.
Okay, 45 seconds. So My position is the evidence is clear. Neanderthal was fully human. They intermated with Europeans and other people groups, for example. This would actually contradict the evolutionary near extinction hypothesis, the out of Africa story, for example. It's more consistent with the multi-regional hypothesis. My question would be, since according to the evolutionary timeline, Dan, Neanderthals split away from the main human population about 400,000 years ago, is what I've read and I've heard in lectures, but was somehow not part of the African near extinction event. Therefore, Neanderthal then reunited, as we know, with the emerging human population, which was only recently coming out of Africa. So my question comes down to, if Homo sapiens went through this radical genetic reshaping in Africa, how did they remain interfertile with Neanderthal? Go ahead.
So first thing is, I'll get to that, but I do want to comment that one, I don't care what paleo experts say on this question. I've presented specific genetic evidence to this point that Neanderthals are descended from Adam and Eve, and the answer is simply that they're not. The genetic data contradict that, and I would love if you would make an attempt to address those specific data, specifically the nesting problem within the hierarchy, within the phylogeny, because in those trees I've showed, the Homo sapiens branches are longer, which is what you'd expect because we've been around for more in the modern times, accumulating mutations. Now, being able to interbreed that doesn't matter as far as being species. There are things basically within a family of things you could interbreed and it's fine, and no one considers things at the family level the same species. The thing I really want to address here is this, and this really is what it comes down to. In the biblical model, it is required, and correct me if I'm wrong here, and I'll ask if you could just give me like a short answer to this question, so I'm on the same page, because I don't want to straw man the young Earth position here. I don't think I am. But in the young Earth model, the common ancestor must be Adam and Eve. And Neanderthals, along with all extant humans, are descended from Adam and Eve. I'll let you go, but just, can I get a yes or no on that?
Ultimately, yes, they've descended from Adam and Eve. Your last Y chromosome ancestor, though, appears to be Y chromosome Noah, though. So would we be looking at, what, I'll share screen and show kind of a little bit of a idea of what I'm talking about here. As I'm sharing, I'll briefly, because I know 90 seconds isn't enough time. So if you want to take a little bit more time next time with the question, because I'm saying that and then I'll get to with what you're saying, the ancestors of Adam and Eve. But the out of Africa itself states that modern humans evolved in Africa, accumulating genetic variation in Africa. Mm-hmm. And portions of that genetic variation then goes out and colonizes the rest of the world, if I'm correct. So this is the genetic basis for the recent out of Africa origin of modern humans. But now because of
rock solid.
Right. So, but here's the major problem is when modern humans left Africa and then colonized the rest of the world, there are other human people groups outside of Africa that we found that, according to evolution, have been there for a very long time, right? Neanderthal, Heidelbergensis, even Erectus, for example, and the Leedy, the Hobbit.
I think it was just Neanderthal and Denisovan, but sure.
So, there's been plenty of overlap with all of those different supposed human species. But according to experts in human evolution, there have been human forms outside of Africa for 2 million years. And most famously, as we're talking about here, the Neanderthals in, I believe, Western Eurasia and other hominins in Eastern Eurasia. So experts in the field have said, and correct me if I'm wrong, that Neanderthals were outside of Africa for approximately, this is kind of the consensus that I found, approximately 400,000 years. Modern humans came into Eurasia and Europe and interbred with these Neanderthals and other hominins. But being separated for that long, according to the deep time evolutionary model, with major genetic reshaping going on in Africa while humans were evolving independently from the other hominins, how did they remain interfertile? At best, they should have maybe remained fertile but produced infertile offspring. But the fact that we've got the Neanderthal genes seems inconsistent with the multi-regional hypothesis. Go ahead, and then I'll go over this slide after.
It is inconsistent with multi-regional hypothesis because the multi-regional hypothesis is wrong. We evolved in Africa, and by we, I mean Homo sapiens, but also genus Homo in general, and in successive waves migrated out of Africa. Yeah, absolutely. Now, I don't have an answer for you of how did we stay interfertile. Interfertility is, it's not that hard. And in the grand scheme of things, humans and Neanderthals we're not separated by that long. And as you've said, our genomes are super similar. The problem here, which I still don't have an answer. So I'm going to share my thing here. Just give me a second here. Let me pull this up.
Did you see my last screen share? Just out of curiosity, I just want to make sure it's working because
I see it. I got it right here. Yeah, I see that it's. Yeah, I see. So when it's back to you, I'll pull it up.
Yeah, okay. Because that's kind of a direct answer to your question. But yeah, go ahead.
This is the key thing right here. Okay. Just going to do this. I'll just do it this way. The key thing, and Standing, I know you like to hammer this point home, is that you've said a lot that it's, these kind of questions all come down to genetics, and also it's all about who's making testable predictions. Well, this slide shows testable predictions right here. Okay, we have testable predictions. We have on top, we have the young Earth creation prediction. Okay, that's what it has to look like. Now you can take that red branch and you could put it off to the side somewhere. You could put it in the middle. You could rotate around the nodes, because in phylogenetics, that doesn't matter. What matters is the pattern and getting back to the common ancestor. And the key thing with the young Earth model is that that common ancestor right there is Adam and Eve. Now, evolution makes a different prediction, and you look at all the available data, mitochondrial, nuclear, Y chromosome, it all works out the same, where Neanderthal genetic diversity is separate from Homo sapiens genetic diversity. And again, there's a misunderstanding here, where it's not that they are super divergent. It's that the markers, the SNPs, the single nucleotide polymorphisms that characterize Neanderthal genomes are different from the ones that characterize Homo sapien DNA. So if Neanderthals were descended from Homo sapiens, which is to say Adam and Eve in the creation model, they need to have Homo sapien genetic markers. Or you're positing that they have lost those markers specifically and preferentially, but have retained the rest of the DNA that stayed the same as they diverged, right? So they lost a bunch of Homo sapiens specific things, but then they kept the rest of the genome the same. And it's while accumulating differences on their own in an own lineage, there's no data to support any of that. We have full genomes, and we agree those genomes are reliable. So we can say like exactly what the relationship between the human genome and the Neanderthal genome. There's interbreeding, but the common ancestor is neither of them. And we're going back and forth on this point, but that node, that common ancestor, it doesn't work as Homo sapiens, and that's the thing. And I still have not heard you attempt to explain why that both is Homo sapiens, but is consistent with the data that shows it's not.
Real quick, before I do my 90 seconds, one real quick clarifying question, hopefully you make it short. Are you at least admitting then that the prediction that we should find more genetic diversity in Neanderthals is an expectation from the biblical creation model? Because wouldn't you agree that inbreeding erodes genetic diversity, therefore it makes sense, according to our model, that they are less diverse due to the inbreeding?
I'm sorry. Should they have, you said it two different ways there. Should Neanderthals, according to the biblical model, have more diversity or less?
What's your position? It sounds like you're trying to say that Neanderthals should have more diversity.
No. Again, this is the misunderstanding here, and this is basic phylogenetics. Okay, it's not that they have more diversity; it's that they are characterized by different genetic markers. It's not that they're more diverse. In fact, they're less diverse. They're inbred, but the markers that they have are qualitatively different from the ones in humans.
But you've said many times that we should expect Neanderthals to be more diverse. You've said it over and over again.
No, I'm saying they should be divergent from humans, not more diverse than Homo sapiens. It's two different things.
But I've heard you say that they should have more genetic diversity. So
I started by saying they're inbred.
But you said that there should be more genetic diversity in. Well, you know what? We can pull that up because I've heard you say that many times. But maybe it's just a slip of the tongue. That's fine. So what we do find, you're right, is we find that they're highly inbred. They had incredible genetic load, 40% less fit than modern humans, all consistent with the Babel dispersion hypothesis. But let me share screen to answer your question.
There you are. There you go.
I gotta say, I think you completely dodged the question because, see, both your multi-regional, you're out of Africa, your genetic data, your paleontology data fits the out of Middle East scenario quite well. The fact that they remain interfertile, according to the deep time evolutionary story, after 400,000 years of separation and genetic reshaping in Africa for modern Homo sapiens, and the fact that they produced fertile offspring and we have Neanderthal genes in our genome is strong confirmation that that deep time history is not true. But if they're just separated for maybe up to 1,000 years, according to the biblical based model, then it makes sense that they remain interfertile. But 400,000 years and they remain interfertile, yeah, that's kind of a fairy tale. So here we got Ham, Shem, and Japheth. Now, according to our model, we assume that the Neanderthal and the other mutant forms of the modern human family, Denisovans, Heidelbergensis, Homo floresiensis, for example, Naledi, we say that they either split away from the Tower of Babel community early. I would say that Neanderthals split away early, which means just before the Babel dispersion, which is why they have that robust physique. You can see in the skeleton itself, you can see these striations that show just how muscular they were. You can see the adaptations to the cold environmental conditions. Now, they were separated from the Babel people groups for so long that eventually, due to the inbreeding, it eroded their genetic diversity to the point where they are different. They are different. Now, you're using your phylogenetic deep time evolutionary assumptions to say, hey, they're a totally different species. They don't fit, the biblical model.
That's time, and you gave me a lot to work with there. So first thing is, I don't care about the skeletons. I just care about the genetics. So I'm going to share the study that's one of my favorite studies of all time that shows that now we're disputing the out of Africa hypothesis. So let me cover that first. So let me show you. This is actually let's see. Here we go. Here you go. So this is actually a slide that I use in class. So what we see here is the population structure of the human phylogeny, and what I want to focus on is this right here on the left, that diagonal line. On the x-axis there, on the y-axis there, you have genetic diversity, and we can agree, I hope, that where humans started, where we radiated from, that's where you have the most diversity. And then on the x-axis, really clever, they have distance to Addis Ababa. That's what AA is there. Addis Ababa, the capital of modern-day Ethiopia. And the dots are color-coded according to where they're sampled from. So red in the top left is African. Then you have green is Europe. The purple is Middle East. You've got Central and South Asia. And then as you move down the line, you've got East Asia, Oceania, and the Americas. And what you can see very clearly is that the epicenter of human genetic diversity is East Central Africa, which completely proves the out of Africa hypothesis. We didn't originate in the Middle East and migrate into Africa. That would make the African populations have less genetic diversity. We started in Africa and radiated everywhere from there. Now, having gotten that out of the way, we're still not addressing the fundamental question of expectations if Adam and Eve are the ancestor for all extant humans plus Neanderthals. Because we're still not communicating correctly on what it means to be divergent in a phylogenetic sense. What we're saying, what the evolution data show, is not that Neanderthals are more diverse. We agree that they are less diverse. They're inbred. We agree on that.
15 seconds.
What those data show is that they are a different clade entirely from Homo sapiens. There are a number of genetic markers that characterize Homo sapiens that are absent from Neanderthals. There are a number of Neanderthal markers that are absent from Homo sapiens. There's a few that we have based on the inbreeding. Now, you could say, well, it strains credulity to think that we could keep inbreeding. There are like fish that diversified millions of years ago that can still interbreed with each other, way outside the time frame that we see here. So if you would mind addressing those specific problems, then I think we should go on to the most recent common ancestor problem and how Neanderthals fall into that.
So real quick before I start my 90 seconds, clarifying question. You said that the hypermutating hypothesis, that they've accumulated more mutations, predicts that the Neanderthals, unless you had a slip of the tongue, that Neanderthals should have more genetic diversity than modern Homo sapiens. Are you denying?
I said that the hypermutating hypothesis is wrong because they are they don't have the genetic diversity,
Exactly.
not compared to modern humans, just in an absolute sense.
No, see, and this is where we're talking past each other. That's where you're 100% wrong. The fact that they were hypermutating and these mutations that have been accumulating for millions of years, because the evolution story says that the vast majority of DNA differences, nuclear DNA differences, mitochondrial DNA differences, were the result of mutations over time. Therefore, these mutations are manifested. The fact that they're inbred means that those mutations that are manifested erodes genetic diversity. Do I got a screen share again? That means
okay, follow up question.
This is
How
my
do
time.
mutations affect genetic diversity?
Okay, mutations, if they are accumulating in the way that they would in a highly inbred population, they will erode, they will reduce heterozygosity. There'll be shifts from heterozygosity to homozygosity. I mean, do I got a screen share what happens?
Okay, I have to tell you that is completely incorrect. If a student gave that answer on an exam, they would get no points for it.
No, that is right.
I'm going to screen share. Mutations, you could pull up whatever slides you want. Mutations increase genetic diversity and necessarily generate new alleles, which necessarily reduces homozygosity.
No, if they're deleterious,
this is not something that's debatable.
Listen, I'm screen sharing. If you can show my.
No, I'll let you show it, and you can explain whatever you want. But I just need to make clear for the audience that you're saying two contradictory things. You are saying that they are hypermutating, and that is leading to the inbreeding and the increase in homozygosity.
Deleterious mutations, though.
Okay, well, that doesn't matter.
Information adding mutations that go on in inbred populations. That's why you see pathology and disease. So it's my time if you want to share my screen real quick.
Your screen shared. I just need to finish my point real fast here, though, because I just want to make sure that everybody's clear on this. You're saying two completely contradictory things. You're saying on the one hand that they're hypermutating. They're generating lots of mutants, which means they are necessarily generating a bunch of new alleles every generation. That's what that means.
Right? No, let me finish. Genetic diversity. This is basic. Dan, sometimes I wonder if you lose your brain.
You can let me finish or not, but like...
Well, this is my time. I just asked for a clarifying question.
And clarifying questions are pausing time and resetting time, given as much back and forth as has been happening.
Okay, Dan, you finish what you got to say, and then I'll start the 90 seconds.
So here's the clarification. There are two different things in population genetics that have opposite effects on genetic diversity. Okay, inbreeding reduces genetic diversity by increasing homozygosity, which is to say,
what I said. I can't believe you said I was wrong, since that's what I said. Increases homozygosity.
I'm not disagreeing with you. I'm saying you're saying two contradictory things.
You said that was give me an F on a test.
Look, listen, I can mute you if you want, because I'm going to get this out, and then you can say whatever you want. But I'm going to clarify for the audience, because you're saying two contradictory things, okay? So here's the problem. One is inbreeding increases homozygosity. That's what inbreeding does. It decreases genetic diversity. You lose alleles, right? You decrease the allelic diversity per locus. On the other hand, you've got mutations. Every time you have a mutation, that's a new allele, unless that particular allele already exists in the population. But in general, mutations generate new alleles. So we have a creationist explanation for the Neanderthal being so different from Homo sapiens, right? And it's that they're hypermutating. Well, that is in direct conflict with Neanderthals being inbred and having high homozygosity. Those two things are directly contradictory with each other. And I want to make this very clear. This is not something that I am saying like Dan Stern Cardinal. This is basic, like population genetics 101. Like, this is not up for debate. These are two things that have opposite effects on genetic diversity. Please square that circle for us.
So, no offense, sometimes I wonder if you're subjectivity, the fact that you're so not objective prevents you from using your brain on this, because the fact is these common alleles that come to the point of fixation, the new alleles that are obviously developed or derived from the hypermutating Neanderthals that are highly inbred, that will reduce heterozygosity. You're going to get more levels of homozygosity, just like it says here, decreasing genetic diversity, because those are deleterious alleles. You can see it here. Thus, the likelihood of deleterious recessive alleles to pair is significantly higher in a small inbreeding population, which is exactly what the Neanderthals are. Maybe we're not going to get anywhere on this one, but I have to say, for the audience sake, you're 1,000% wrong on this. I've double checked this over and over again. The fact that they were hypermutating due to being a small inbred tribe means that those mutations that come to the forefront, the ones that are manifested, evolutionists are the ones that assume all DNA differences are the result of mutation over time. They erode genetic diversity, and those alleles that come to the forefront that are generated are deleterious. So I'm not too sure what you don't understand about that, but maybe you just want to argue. Now the thing is,
no, I mean, Standing, to be completely honest, I want to make sure the audience doesn't come away with the wrong impression of how population genetics works. I can't believe we're sitting here disputing the fact that mutations increase genetic diversity. Everywhere else, you talk to creationists, and what do you get? Oh, evolutionists, they claim that how do you get new stuff? Oh, it's through random mutations. Like, this is just basic population genetics. This isn't even controversial. More mutations, i.e. being hypermutable, increases the allelic diversity of a population. Like, that's just, I
wasn't sure if my time down there. It was my time. So in small population sizes, which is exactly what the Neanderthals were, inbreeding or mating between individuals with similar genetic makeup, if you can see my slide here, is more likely to occur. And that's exactly what did occur. Yeah. Thus, perpetuating more common alleles to the point of fixation, thus decreasing genetic diversity. And this is exactly what we see. So I don't know what the point of contention is. The point is, I wish you would just agree that what we see in terms of genetic diversity in the Neanderthals is not inconsistent with the biblical creation model. If you don't want to at least agree with that point, then that's fine. We can move on to something else.
All right, let's move on to most recent common ancestors. Then we have a few minutes. We have about 10, maybe 15 minutes, about 15 minutes before we go to closings. So let's agree to disagree that mutations do or do not increase genetic diversity. Spoiler, they do. This is not controversial. But let's move on to most recent common ancestors. So you're very familiar with Jeanson's math, Jeanson's very wrong math, that the mitochondrial most recent common ancestor for humans was 6,000 years ago, and the Y chromosome most recent common ancestor was 4,500 years ago. Now, he bases that purely on Homo sapiens DNA. He doesn't consider Neanderthals in those numbers. And he, in fact, claims that Neanderthal genomes are unreliable. He just basically writes them off. Now, we agree that that's wrong. So what you need to do, since you accept that Neanderthal genomes are reliable, is explain how that fits into the young Earth most recent common ancestor calculations, which, by the way, are already wrong. But if you add a whole other set of genetic diversity that's outside the range of existing Homo sapiens diversity, you end up causing a bigger problem for the young Earth model. Now, if you treat the data correctly and you do the correct techniques, you find that the human most recent common ancestors, the earliest one, the mitochondrial most recent common ancestor, would be 60 to 200,000 years ago, and the Homo sapien Neanderthal common ancestor is somewhere in the neighborhood of 500,000 years ago. But we're going to pretend that's not the case. We're going to accept Jeanson's math. Please explain, because he discounts Neanderthals. So please explain how Neanderthals fit into the biblical model, when even Jeanson admits that if you include them, it breaks the most recent common ancestor dating.
Awesome. Yeah, if my 90 seconds starts now. If it got a little heated there, I apologize. We're both passionate. This is fun. This has been a good discussion. So real quick, yeah, I would agree with you that the fact that we see the Neanderthals all grouped together, just like the rest of humanity, should be solid indication that what we are looking at in terms of DNA is not chemical damage. All the Neanderthals are exactly alike, and the DNA analyses that we have actually places them together in the same group. So I agree that what we have is reliable. But I also believe that what we see in terms of the highly inbred nature of the Neanderthals that's reflected in their genome is perfectly consistent with our model of either post or pre-Babel. I will get to what you're saying about the most recent common ancestors. I do want to point out to the audience, I think you wanted to avoid the archaeology and all the other things that I said in my opening that suggested they were fully humans, and the fact that paleo experts agree that they're Homo sapiens, because it doesn't fit your preconceived idea.
For the record, I am ignoring that stuff because you wanted to. Well, actually, no, I'm going to respond to that real fast. I'm ignoring that stuff because you reached out to respond to the video I made on this topic, in which I only talked about genetics. So that's why I'm
emailed you to say that I want to debate whether or not they're humans, and you said, well, this title is more or less the same. I'm showing you from all types of fields that it's kind of it's contradictory, because oftentimes when evolutionists point to transitional fossils and you point out that those don't have genetics, and genetics is what's inherited sperm and egg, and they say, well, I mean, we can get information from bones, but now you just want to focus on the genetics and ignore the bones. So I agree with you that genetics is the most important way to determine ancestry. I agree with
the genetics.
So now, to end the other topic before we get into the most recent common ancestor, the whole time you're trying to argue from phylogenetic trees based on evolutionary assumptions about Neanderthals. Those have no bearing on this discussion whether or not our model is true. Those lines on paper can be based on real evidence, or they could be arbitrary. For example, the ones that you're showing on the Neanderthal, because you assume that what you're saying about deep time evolution and Neanderthals being a separate species to be true. We don't have to follow those clades with human beings because they're on the same tree. So the fact is, what we see is more consistent with Shem, Ham, and Japheth. And you got these lines, and either you've got these groups, and I showed this on the screen, you've got these subgroups, Neanderthals, Denisovans, Heidelbergensis, whatever, Naledi and Floresiensis, of course, that are branched off and oftentimes look like a sister group, but they're just highly genetically compromised. Thus explains why they, like the Neanderthals, 99.7%, but 99.7%, what more do you want? It's been thousands of years. Of course, there's going to be some genetic markers that have accumulated. There's going to be some differences that reflect some differences between Neanderthal genetics and our genetics, but every field confirms that they are 100% human. And I don't know why you are so reluctant to accept that. And I didn't have time for your next question, but I wanted to end that portion on Neanderthal with those sayings. Go ahead, Dan.
Okay, I mean, that's the whole question, though. You're saying they're human. They're descended from Adam and Eve. They are Homo sapiens. So now you have to reconcile that with the genetic data that creationists say points to a 6,000-year most recent common ancestor when you don't include Neanderthal DNA. So on this tree right here, actually, let me go down to right here, right? So the arrow that ends more to the right, okay, that's what Jeanson points to, that node. The human most recent common ancestor. That's the one that Jeanson says for mitochondria 6,000 years. Now, we agree that Neanderthals are different from humans genetically. They fall outside the range of Homo sapiens genetic diversity, which means necessarily that they have a common ancestor in the more distant past. That's the arrow that ends to the left there, right? It's the one that's further to the left. Now, what I heard a lot in there, but what I didn't hear is any attempt to reconcile these genetic data, the greater divergence from Homo sapiens that we find in Neanderthals, again, not degree of difference within Neanderthals, but divergence from Homo sapiens. What I did not hear is any attempt to reconcile that difference and the necessarily more distant most recent common ancestor with the existing biblical model and the existing creationist writing on this topic, which, again, specifically excludes Neanderthals from that discussion, right? So I would love it if you would attempt to address that problem.
Thank you. Before my 90 seconds begins, just want to make sure my screen is shared.
Up here. There you go.
So, and thank you for that. This is, overall, this has been a great discussion. I just want to point out for the audience's sake that I think it's obvious that you're just avoiding every which way to admit that Neanderthals are obviously human. Even this latest paper, 2020, for example, ancient humans, Neanderthals, and Denisovans were genetically closer than polar bears and brown bears. And so, like the bears, were able to easily produce healthy, fertile hybrids. Now, the thing is, you won't explain how after 400,000 years of genetic reshaping and genetic change independently with Homo sapiens and Homo Neanderthal ancestors, we're still able to produce healthy, fertile offspring. Yeah, that's a fairy tale. Now, I've already answered your question. The major increases in the differences with Neanderthals and modern Homo sapiens comes from the fact that Neanderthals died 4,500 years ago, or maybe 4,000, depending on when they went extinct, if it was pre or post-flood Babel, and humans kept living on. So even you would have to agree that humans are going to accumulate more genetic differences. Of course, this is just basic population genetics. The fact that they were inbred just sped up the process that much more. That's why you see that their bodies are very robust. They're adapted to their ice age environments. They were muscular. I know you don't want to look at those things, but that superiority in a negative environment will accelerate genetic degeneration and erode genetic information. Since I only have 15 seconds, I'm sure we're coming close to the closings, but I'll answer your question on the mutation rates from GeneSyn after. Go ahead.
I mean, I'll give you a third attempt if you want. Would you like to address the phylogenetic data? Could you address the problem of the most recent common ancestor for me? This is the third time I'm asking. I don't think you're interested in answering the question. Or maybe you would just want to keep the answer secret. I don't know. But would you like to address those specific data?
Are you trying to say, how do we reconcile the Neanderthal data with the most recent common ancestor in mitochondrial DNA?
Yes, because Nathaniel GeneSyn, who is what creationists always go to, his data on mitochondrial Eve is what creationists cite. And he puts those data at 6,000. He puts that date at 6,000 years ago. He specifically excludes Neanderthals from those calculations. Neanderthals have a different set of genetic diversity compared to humans, which means you need to go back
they went extinct
further.
or assimilated.
It doesn't matter. Their genetic diversity existed, and you're claiming they're descended from Adam and Eve, which means if you're going to reconcile those two things, you need to go back.
They were a subgroup that hypermutated to oblivion.
So you're falling back on hypermutation again, which does not. There's no data to support that. Because again,
are you kidding me? That's exactly what we see. The papers and the information that I showed. I mean, do I got to show this paper again?
So Standing, you're giving me morphological data as a proxy for genetic data. I'm giving you the genetic data. We don't have to use the morphology to say like, oh, they must have all these mutations. Fine, they were inbred. They had a bunch of homozygous deleterious mutations. I agree.
There you go.
We don't need to wonder about how that affects their phylogenetics. We have that answer because we have their full genomes. Hypermutation increases diversity, but we see them having inbreeding. So
not if it's deleterious alleles that are eroding genetic diversity.
No, you can't invoke hypermutation within that same time frame because they're inbred.
What's the hypermutation due to?
The hypermutation, what's it due to? Faster mutation rates is what hypermutation
because
does.
of the inbreeding and the small population.
That's not what inbreeding does. Inbreeding increases genetic drift, not mutations. Genetic drift decreases allelic diversity, not increases it. Standing, I gotta say, like, this is...
Inbreeding reveals and manifests the hidden reservoir of genetic mistakes that you say have been accumulating. They've been accumulating for millions and millions of years. Now they're coming to the forefront.
Let's look at it this way. If I'm heterozygous for a particular gene, how many different alleles do I have for that gene? Just
more than two.
Two. If I'm homozygous,
or you could have more than
how many
two.
alleles do I have for that gene? How many distinct alleles do I have for that gene?
You'd have the same. You'd have one.
I have one. Okay. So if you're inbred and you're increasing homozygosity, you are necessarily decreasing heterozygosity. You are decreasing allelic diversity. Now, if you're hypermutating, if I have a set in a population, I have a set of alleles for a locus, and a bunch of them mutate, now I have a bunch of new alleles in that population. I'm increasing the genetic diversity. That's the opposite.
If those are deleterious alleles?
It doesn't matter the fitness effects. What matters is whether they're the same or they're different. That's all that matters. If you're hypermutating, you're increasing the number of alleles, and if you're inbreeding, you're decreasing them. We see inbreeding Neanderthals. You can't invoke hypermutation to squeeze them into the appropriate timeline. It just doesn't work.
If you're hypermutating and you're accumulating these deleterious mutations due to the inbreeding nature of the Neanderthal populations, you're saying that's not going to erode their genetic information?
I'm saying it doesn't matter. I'm saying we can document their genetic diversity. The effect on fitness, the effect on information does not matter. What matters is their allelic diversity. For these calculations, what matters is their diversity.
Right, and their diversity is very highly homozygous due to the inbred nature of the Neanderthals.
So is that a lot of diversity or a little diversity?
That's a little diversity.
Exactly, which means they're not hypermutating. Because if they were hypermutating, we'd see a lot of diversity. We'd see lots of new mutations accumulating.
That hypermutating hypothesis may be misleading because, for example, it would be the manifestation of mutations that are in a recessive state.
No, that doesn't matter.
Come to the forefront to erode genetic diversity.
No,
so
that doesn't matter. It doesn't. All that matters is the number of variants. It doesn't matter what effect they have. We have the genomes. We don't have to wonder if they were hypermutated. We don't have to wonder how many alleles they had. We have the genomes. We know the answer. Like, it's an open shut question.
No, I don't think. Okay, why were the Neanderthals so highly homozygous?
Because they were
Why
inbred.
are they 40% less fit than modern humans?
I don't know where they get those numbers. I don't necessarily think those numbers are valid because I don't think we can measure the fitness of fossils. As Kent Hovind is fond of saying, we don't know if they had kids, right? So I don't care about that 40% number. What I'm pointing to and what you're not
a recent
addressing is whether or not Neanderthals can be squeezed into the young Earth 6,000 year timeline. You know what Nathaniel Jeanson's answer is? His answer is no. His answer is, I don't have to look at those genomes because they're degraded because they've been sitting out in nature for tens of thousands or however long he says. That's his response to that. Now, your response is different. Your response is that those genomes are perfectly valid. I agree. But that means you now have to fit them into 6,000 years. If we can only just barely cram the Homo sapiens, the extant Homo sapiens, into a 6,000 year timeline, you add a whole other set of alleles that need to be crammed into that timeline. You're too far in the past to adhere to a biblical timeline now. That's the contradiction at the heart of this, and that's what you're not addressing. It doesn't matter. Deleterious doesn't matter. What matters is how many alleles and how much diversity there is.
Okay, let's just go back to the 90-second thing because I'm looking at everything I wrote down. I believe I have answered your question on that, and I believe that it's clear that the inbred nature of them would erode the genetic diversity. They're 99.7% similar to us. And of course, there's been genetic changes since their extinction thousands of years ago versus modern humans. So that explains those differences. We're just going to have to agree to disagree. You keep saying I'm wrong. I see no reason why I'm wrong. I've showed all the sources that show inbreeding reveals the hidden reservoir of genetic mistakes that have been accumulating over time, and they erode genetic information. I mean, to me, this is pretty basic. But let's go back to the 9 because there's one thing I didn't address. I feel like I've addressed everything except for you saying the epicenter of genetic diversity is in Africa.
You're saying that is absolutely. It's not true. You keep using this phrase, hidden reservoir of genetic diversity, right? And what I think that means is you've got a bunch of alleles in the genome that are recessive, that are harmful. The problem is it doesn't matter if they're hidden in the lifetime of the Neanderthals. What matters is we have their genomes now. They're not hidden.
But when they're deleterious, they erode genetic information.
Explain why that matters, please. Why does it matter if they're deleterious?
If they're a deleterious mutation that are coming to the forefront due to the inbreeding, inbreeding by definition,
why does that matter for the
diversity?
Why does that matter for the diversity?
Okay, all the secular papers and paleo experts
no. Don't go to all these.
They were highly homozygous due to this.
Matter for the diversity? Why does it matter that they're deleterious? What effect does that have on the diversity?
I think you're just playing semantics. We know the cheetahs today have very low genetic diversity. Okay, for example, humans are 99.9% similar. Now, the way the evolutionists get around this, the fact that there's such low genetic diversity, is they've invented this extended hypothetical population bottleneck into the South Africa scenario where there was inbreeding that reduced levels of homogeneity. So I just think you're playing games here to get around with it. So I don't want to think we're going to agree to disagree on that topic. I need 90 seconds now to address your out of Africa situation. We're going to have to agree to disagree on that because the cheetahs are highly homozygous, low genetic diversity. Humans have low genetic diversity that the evolutionists say is due to the out of Africa population bottleneck. Neanderthals have low genetic diversity because they were highly inbred and existed in small isolated tribes. Like, I don't know what you're disagreeing with here, Dr. Dan.
I'm agreeing with those things you just said about bottlenecks and founder effects and isolation inbreeding. I agree with that stuff. That's all. We have data on that. That's totally good.
Okay. Let's get, I don't know who wants the next 90 seconds, or would this be let's do one more 90-second interval.
Let's do one more real fast, and then we can wrap it up. Here, go ahead if you want, or I'll just flip through my slides and see if there's anything else I wanted to address. I mean, I think I'd be better served just pulling up a textbook or something.
So I would say the genetic differences that we see in the African populations, because that's where we see our biblical perspective is that man came out of the Middle East, Babylon, for example, in the recent past. Now, on a global genetic scale, okay, Mesopotamia and northeastern Africa, which is what you're saying is the epicenter for genetic diversity, are essentially the same.
Not what I'm saying. No. That's not what I'm saying. It's East Central Africa, Sub-Saharan.
These areas with the Middle East and the epicenter of genetic diversity in Africa are so close that a lot of the times it's where do you put it? And the genetic differences between the people groups spreading out after Babel would have logically resulted from you've got the fragmentation, obviously, of the original gene pool, which is what we see. We see that many subpopulations, like your mutant forms of the hominins, for example, they went into extinction. Those mutations mutated them to oblivion. But the higher level of genetic diversity in Africa, I would agree with Dr. Rob Carter. From my understanding, Rob Carter, John Sanford Tompkins, Dr. Todd Wood, they agree that the Neanderthal DNA is reliable. So I'm with them on that. I'm not sure how Jeanson would respond to what we're saying here. I don't know, but I don't, So after the Tower of Babel event, they would say more tribes moved into Africa than into Europe or Asia, and that the African tribes remained smaller in size and were more isolated from each other for a longer period of time. So a combination of those factors would actually be reliable to the genetic reality and the biblical creation model. It would be reliable with the multi-regional evidence as well as the out of Africa evidence. That's really all I got to say in terms of. You could have one last word. We can do a closing statement if you want.
So let's do. Let me just get one last thing in here. Is that you're still not correctly saying how different things affect genetic diversity. So, like for example, the African groups, if they migrated from the Middle East, you have the full suite of genetic diversity in the Middle East, and then through what's called a founder event, you have some subset of that diversity migrating into Africa. The subsequent population structure within Africa doesn't matter at that point. You've lost a bunch of genetic diversity. You can also gain new alleles, but it'll always be representative of a subgroup of the outside of Africa genetic diversity. What we see, and this is because, as you said, these are small. They'd be smaller groups. They'd be more isolated in this scenario, and you'd experience inbreeding and genetic drift, and you would lose allelic diversity through those processes, as well as the original founder events. It wouldn't just be one founder event. It would be serial founder events as you migrated, right? Now, what we actually see in Africa is more genetic diversity. You could pick African populations from a few hundred miles apart, and you will find more genetic diversity than you will between any two people in the world outside of Africa. You could pick someone from Ireland and somebody from an indigenous South American population. You will find fewer differences between those two people than you will between two random African populations just a few hundred miles apart. The reason for that is that Africa is the site where humanity originated. That's where most of the genetic diversity is, and only a small fraction of that migrated out of Africa. And then of that amount, you had subsequent founder events into South Asia, into Europe, into Northern Europe, into Central Asia, East Asia, Southeast Asia. And you can make really cool predictions about this and how it correlates with archaeological evidence. And one of my favorites is just how you can look at indigenous populations in Madagascar, and you find that they're actually more similar to Southeast Asian populations than they are to sub-Saharan African populations, because Madagascar was only settled about 1,500 years ago via migration across the Indian Ocean from Southeast Asia. So, I mean, the data corroborate an out of Africa model, and what is a question is how much interbreeding we did with groups like Neanderthals and Denisovans. What is not a question is where humanity came from and how we radiated outwards from there. So with that, I will turn it over to you if you want to do your opening, or I'm happy to let you go last if you want me to do or your closing rather, or you can go last if you want to do that. It's up to you.
No, if we want to make this the closing statement, that's fine. How many minutes do I get there, Dakota?
I think like 5-ish.
Okay. So
like 5-ish.
I will. Awesome. So I appreciate the discussion. I appreciate everything that's been stated here. I don't want us to, go in too many circles, but I think the genetic data, you can see I'm sharing screen in inbred Neanderthals, left humans.
I got you. Just a second.
That's okay.
There you go. Sorry, didn't see you were sharing.
And I'm you said you don't necessarily agree that they were 40% less reproductively fit than modern humans. And you can look at these articles and the papers associated with themselves and read them for yourselves and see why they're concluding that the Neanderthals were highly inbred, they carried a high genetic load is the point. Even here shows in Eric Trinko's paper that Neanderthals had high levels of homozygosity. We seem to agree with that, of course. And everything seems to indicate that, these Neanderthals were nothing more than just human people groups that became isolated post-Babel. Here's the slide I'm looking for. According to our model, you'd have your modern Homo sapiens that are migrating, and you would have some of these subpopulations break off. Neanderthal, of course, Denisovans, Heidelbergensis, hobbits, which are Homo floresiensis, and these would have become highly inbred, genetically compromised, and probably resulted in their extinction. Now, since the extinction of the Neanderthals, there's been some genetic changes, of course, new alleles added to the human population through mutations. One way because our model is the created heterozygosity hypothesis that suggests in maybe our next discussion, since we're focusing on specific topics, I like this, Dan, we can just focus on the created heterozygosity hypothesis, but we'd suggest that the vast majority of DNA differences are the result of creation. These DNA differences and these alleles. Now, one way we can determine which ones are created and which ones are not is we look at allele frequencies around the world. We can see which ones are rare and which ones are common. And the ones that are common are most likely created, and the ones that are rare are mutations post-Babel, given enough time to become fixated, for example. So we could talk about that in more detail in another debate solely on that. But, the DNA analyses, since we are focusing on that, not only with the Neanderthals, but also with the Denisovans, for example. And I would imagine it would be the same if we had DNA from Erectus, Heidelbergensis. We can see that they were all, at least if we look at the biological species concept, which Dr. Dan doesn't really agree with. It's kind of arbitrary, which I see his point there, since there are some species, of course, like dogs that are considered different species, Canis lupus, Canis domesticus, Canis coyotes, and yet they can still interbreed. But there are some paleo experts, the lumpers, where they lump all these different so-called human variants into the same species. But as I indicated earlier, with the form of the Neanderthal, their DNA, obviously, if you look at the 99.7% similarity with them and modern humans, that makes sense. We're all 99.99%, but there's been some genetic change since the extinction of the Neanderthal. So that's perfectly consistent. I'm not sure what anyone else would want in terms of demonstrating that Neanderthals are human. This whole pathology and disease and inbreeding is not uncommon in the fossil record, as you can see here from Eric Trinkos' paper. But there's one other, and the fact that we see recent humans with the same archaic features as the Neanderthals, not only in this boxer here, but there's been fossils discovered that the evolutionary community admits is far too recent to actually be Neanderthals, and yet they have the features identical to Neanderthals that they themselves will admit are Homo sapiens. So a lot of this is just due to adaptation and the conditions associated with the Ice Age, of course, which is all corroborated by the paleo experts themselves. So I think that's all that I would have to say. Dr. Jensen and his mitochondrial DNA mutation rates, Dr. Dan and I have talked about that extensively. Since you're going to end it, you can respond to this if you want, but I've always made the point that there is agreement between two major mitochondrial DNA mutation sets that actually exist. The one that Dr. Dan and I have discussed extensively, and he can have the last word on this, looks at the D loop, which is the coding region. He says it's highly variable, but it is germline. We know that. And that mutation rate has been corroborated by mutation rate sets that look at the entire mitochondrial genome. And Dr. Jensen, for example, has looked at that data, and they all corroborate with of course, the D loop results. And the point is, it's my position that we can be confident with an accurate germ cell line mutation rate that leads to testable predictions on the history of civilization and predictions on people groups where we don't know their mutation rates, like the Khoisan people. So we've talked about that heavily. I'll give Dr. Dan, the last words on that one. My question would just be, hey, listen, if these are somatic mutations or we have to consider substitution rates, why are the predictions working so well? I predict Dr. Dan will say they're not working so well, but he needs to read the last few papers that Dr. Jensen has put out regarding genetic stamps in the Y chromosome, for example, that corroborate a 4,500-year date to Y chromosome Noah. Maybe he's read those. He can answer that question and give his thoughts on that. So I've had a good time. We've talked about a lot. Maybe the next debate can be created heterozygosity, but last word goes to you there, Dr. Dan.
That was about 5.5 minutes.
So first thing is the most recent common ancestor dates are completely separate debate, and I would love to have that debate, let me tell you, because I got a lot of thoughts. So I'd be happy to talk about created heterozygosity or the most recent common ancestor dates as determined by one Nathaniel Jensen, but I'm not going to address that here because that wasn't the topic of this debate. This debate was about whether Neanderthals are descended from Adam and Eve, right? Are Neanderthals Homo sapiens? And in the creation model, that means, are they descended from Adam and Eve? And I presented 2 lines of genetic evidence that shows that the answer is very clearly no. And I also addressed the main creationist, if I could borrow a phrase that Standing is fond of, rescue device, and showed how that's incompatible with both the actual data and the biblical model. And I asked several times if Standing could address those specific things, and he basically declined to do so repeatedly. So that's basically my closing for this discussion. But I do want to finish with kind of a note on the side, and it's this. It's that for Standing and the whole Standing for Truth group, I would ask that you have some humility when you approach these discussions and think about what your goals are and how you can achieve them. My understanding is you don't have any formal training in all of this, which is great. I love people that want to just dive into biology topics. I think that's wonderful. But you've written several books. And by the way, I'll take this opportunity to invite you to when I talk about them, because that would be rude to talk about you behind your back. But you've written several books in which you, at best, provide no evidence for your claims, and at worst, misrepresent current scientific findings and commit egregious basic errors in terms of biological concepts. And we saw some of that here right now with the misunderstanding of how mutations and inbreeding affect genetic diversity. In writing and in debates like this, I'm repeatedly seeing these kinds of basic errors, things that are so basic that my undergraduate students would catch the errors. And when corrected, you don't change what you're saying. It's just, it seems to be in one ear and out the other, right? And you all want to overturn the scientific consensus on evolution? You want to be taken seriously? Act like it. Learn what the field of evolutionary biology is actually all about. Now, in spite of this just general lack of basic knowledge about evolution, we like to have these pretend debates, right? And I want to be clear, this is on this question or any other question, how old is humanity or whatever, there's no actual debate going on these questions. This is not taking on what you're doing here is not taking on the scientific establishment, right? This is cosplaying scientific discourse. I do this because it's fun, because I like biology, and I'm first and foremost, I'm an educator. So I'll take any opportunity I can get to present biology to an audience that might not otherwise be exposed to it. I also think it's really important to address bad ideas and flawed reasoning in general so that people can recognize that and be able to point it out in other contexts. But what's the point from your perspective? If you're trying to overturn the scientific consensus, this is not how to do it. The way to do that is to do the work. Put in the time, do the research, publish your data and defend it. Convince people, convince me. I started today in my opening by saying, here are the exact problems I have with the thing you're claiming. And I asked several times, can you address these specific problems? Because if you want to convince me, the thing you do is you show that those problems are wrong, right? But instead you talk about fossils and, pathologies and whatever, and don't actually talk about the question at the heart of the matter that's actually going to do the work of convincing people that your model is superior, right? So YouTube debates are fun. I had super fun last week when you hosted, and thank you again for that, when you hosted Ken Hovind, that was super fun. But that's a sideshow. From what I can see, Like, that's what creationists seem to be interested in, this kind of public show of debate without actually doing the work of the science, right? And that's not just like, I don't want you to feel like this is aimed just at you. That's true for you and Rawmat and like everyone up to, Behe and Jensen, right? Because they're publishing books and getting into blog fights with people on the internet instead of like actually publishing their work in journals. So what I want to finish with is, think about what you're doing and why. If you want anybody outside of your circle to take you seriously, like, start acting like it. Don't come in here and like dispute how mutations affect genetic diversity in a population. Like, and this goes for everybody. This goes for, Maddox, Neff, Rawmat, like whoever. Like, if you want to debate the science, you want to convince people that you're right and the science is wrong, like, start by learning the science. And like, you're welcome to come on here anytime. And that goes for, everybody. I got an open door policy, right? But like, if you're actually interested in like having that debate, instead of preaching to the choir, like, act like it. Don't don't come in here and just like dispute basic facts about how biology works. It's not the appropriate approach for something like this. Thank you.
Dan, and not to continue the argument, but my question, it can be yes or no. You can elaborate on it. Would you say that people like Jensen, Tompkins, Behe, Rob Carter, Dr. Sanford, would you say that they misrepresent the science in their writings and publications?
Yeah, I would. And I'd be happy to talk to any of them and tell them that to their face. Yeah, they do. Like,
so I'm in pretty good company then, eh?
Okay.
Okay, well, so
let's go to questions. What do we got?
Let's try and make the questions not too much of a back.
Yeah, it's 11. So it's 11 o'clock. What do you say to we say 11:10 or 11:15? Like, we'll be
good idea.
Around.
Yeah, we agree on that.
I'll put them in our sub chat just to refresh them all through. There's 13, 14 questions asked in total.
All right, lightning round. How does that look like? Yeah, so, we'll see how far we can
first
go.
One was from Dapper Dinosaur for Standing. Why does your air quotes, Neanderthal example of a modern human have a chin and no occipital bun?
Why does the example that I gave? Well, the Neanderthals, we've covered this in great detail. When they say it's no chin, it's more accurate to say a reduced chin, which is oftentimes related to the adaptation, the adaptive events associated with their ice age conditions, as I provided a few citations for in my opening, where it's agreement that those adaptive events occurred to them living in cold environments. But we can see great variation in the same bone beds. There's one bone pit actually where it was clear that it was an erectus skull. There was some variation that indicated Neanderthalensis and also erectus and modern Homo sapiens. And they ended up concluding, because it was in the same pit, that it was all Neanderthalensis. And they even admitted that, if these were found in isolated areas, they'd conclude different species. But because it was in the same bone, and this happens over and over again, if you want citations, I can post it later. When it's in the same bone pits, they oftentimes have to agree that, okay, this is the same species. They're found together. But the reduced chin.
We gotta go fast.
Yeah, that's it. That's it. If you want a response, you can go ahead, Dan.
I mean, the answer is Neanderthals never had a chin. Like, they don't have chins.
They had a reduced chin, but there was a bit of a chin there.
Only Homo sapiens have chins. All right. Okay.
Luca, I'm gonna butcher this. Sorry. Dugno, for SFT, do you have a degree not relevant to debate, not curious? And that might reveal too much information if you feel.
So yeah, if you don't want to answer that, you don't have to.
I'm not sure. What was the question?
Do you have a degree, or if not relevant?
It's in the private chat, by the way.
But yeah, I don't think it's probably. Yeah, if you feel uncomfortable sharing that, no need to.
I used to share what my education is in, and then unfortunately, and I like how we can all have good discussions and never take it personal. But yeah, years ago, somebody obviously took it personal and tried to attack my my license in the field that I work in. So I'd rather keep that a secret now.
That's fun. Right. Next one is a question for both of y'all. On Eva versus creation, debates emotions are in high. Sometimes unshareable, dishonest arguments are made. Can each of you cite an argument that you've seen from your own side that is like this?
Anything Richard Dawkins says about atheism.
So arguments on my side that I agree are not good arguments or dishonest? Is that what the question is?
Yeah.
I would say that anybody who says that, there's absolutely no evidence for universal common descent, I believe that a lot of the evidence can certainly be interpreted that way in regards to nested hierarchical patterns in anatomy, physiology, morphology, and genetics, and the evidence in pseudogenes, retroviruses. These are lines of evidence that I believe we should take seriously and we should take the time to address. And that's why I always say it comes down to the differentiating evidence. But yeah, I would say any apologist that just blatantly says there's no evidence for it. I mean, there's evidence that deserves some discussion and some examination. So.
All right. And next up was TD Lane asking for standing. Wouldn't new genetic markers be new information?
New genetic markers. I'm guessing about the new alleles that would. That I've said can come about through mutation, post-Babel, dispersion. If it's a change in just like, let's say it's a change of a protein sequence that already existed, it's an alteration. Is it new information? That's why typically when I debate it, I think because typically the evolutionists will agree there's a trade-off. Yeah, we see a loss of information. A lot of times these beneficial mutations are environmentally dependent. Me and Dan can have a whole discussion on this in a time in the future. I think the appropriate question is the trade-off sustainable? And it comes down to the net gain versus net loss. So,
all right, thank you. This one is for Dan from Zap Brannigan. Brannigan. If talking in terms of species is confusing, what is the better/newer way to look at it?
Lineages. The answer is lineages, people. We need to be thinking about common ancestry, lineages, and subsequent gene flow. If you have a common ancestor and the descendants, and everybody is like within vertical transmission of genes, there's all gene flow going on in there. That's what you call a species, if you must use a species concept. All this other stuff about morphology and interbreeding, it doesn't work across wide ranges of organisms. It's very mammal-centric. The better way is just look at the evolutionary histories and consider independent lineages. That's what matters.
All right.
I'm a curmudgeon on this.
This again by Luca Mendugno. How many hominids came from Adam and Eve in your model to standing?
Question.
How many of the hominins are direct descendants from Adam and Eve?
Yes, I think that's what the question is.
At the top of my head, I would say those that are of the humankind, therefore they'd obviously be descended from Adam and Eve, would be Heidelbergensis, Neanderthalensis, Naledi, Homo floresiensis, Ergaster, Erectus. A lot of them are just variants of Erectus. I know that even the paleo experts agree that like the hobbits are just a degenerate or a dwarfed form of Erectus. And then my position that most of your Australopithecines are just an extinct ape genus. And well, I don't want to go on. I don't want to bring something else up that might go on a rabbit trail, but I believe that there's some artificial species out there as well. So at the top of my head, those are the ones I would say are human.
All right, next up, I think this one was partially covered, but for standing from Corporal Anon, why does Jensen think the Neanderthal DNA is unreliable? Why do you not agree with him?
Good question. I did kind of well, I think me and Dan both covered it in great detail. He believes that it's not reliable due to the fact that DNA can go bad quickly, and therefore if that DNA was sitting around in the bones for thousands, I guess according to the evolutionary model, maybe tens of thousands of years. We know that when we put DNA in a fridge, when it's fresh from an organism, it goes bad pretty quickly. So how can we be sure that this is reliable DNA? I would say, so his position is DNA degrades too fast. Therefore, what we're looking at is more so chemical damage. And Dr. Dan can elaborate on this if you'd like to. But I just believe that, one thing is we can also just sequence the same DNA sample over and over and over and over again and make sure we got it right. And we can typically recognize chemical damage or contamination, because a lot of times they'll say contamination. Let's say you get a piece of your hair falls in or a little bit of dandruff. Well, we can focus on the ends of the DNA samples that give us the best results. So I just believe the consistency of it. You get Neanderthal DNA from Spain and Neanderthal DNA from Siberia. Why is it so consistent and why do they all group together? So that's my position. You can say something, Dan, if you'd like.
No, I agree. If it was broken down, it would be divergent. It's very consistent, indicative of inbreeding. It's not broken down. It's perfectly reliable. Jensen is wrong.
All right. This was from Gonna Go For It. Is Standing claiming Noah's wife gave birth to different species, or did they evolve at later time?
No, I don't believe that, like Noah, I don't believe that his kids or their kids were, I don't believe that they looked like Neanderthal. I don't believe that they look like Erectus. I just believe that they were modern Homo sapiens. See, the thing is, the out of Africa story, or I should say the evolutionary story when it comes to human evolution, is that Erectus evolved into Homo sapiens. And there was an original out of Africa where Erectus left Africa and independently would have evolved into like Neanderthals and some of your other hominins. Our position is quite the opposite. It's that Erectus, it's that Homo sapiens, due to pre and post Babel dispersion events, would have devolved into your hominins. So it's kind of the opposite. But no, Noah and Noah's kids, the ones that weren't degenerate, they wouldn't have looked like Neanderthal or Erectus. But good question, actually.
I just want to say that devolution is not a thing. There's no inherent directionality to evolution. So that's not a thing.
All right. Next up is from everybody's favorite Gutsit Gibbon for asking for Standing. Why are you comfortable using genetic similarity to lump Neanderthals as humans at 99.7, but you reject the chimp similarity of 98.8, which was acquired the exact same way?
Good question, I guess. And Eric and I can discuss this in great detail because I know she's reading my most recent book on human evolution. We're going to discuss these things, but it comes down to how do we determine ancestry? Obviously, there's two competing hypotheses. The evolutionist says that the vast majority of DNA differences are the result of mutations and genetic mistakes over time, while we invoke created heterozygosity. Therefore, that's why we look to, like someone like Dr. Jensen looks to molecular clocks. The actual genetic percent, like the relative percent differences, cannot always, because it appears since God created two people, Adam and Eve, while we'd expect low genetic diversity, it seems the animals were created with a greater ability to diversify. So that's why, the actual percent difference is not always the best indicator of what's related and what's not related. So.
All right.
So it's arbitrary.
The follow-up was by Gutsit Gibbon again. For Standing, what anthropologists are saying Neanderthals are human that aren't just meaning as, again, air quotes, just a part of genus Homo?
A good question. That's why I clarified by asking Dr. Dan if he agreed. Like, you've got lumpers and splitters. Your lumpers typically will just lump a lot of the different variants into the same species due to the ability to interbreed, for example, while your splitters kind of split them up almost due to any little morphological difference. But a lot of paleo experts, I got a lot of papers here that suggest that they are the same. Sure. Last name Pabo, I believe, Paabo. Let me see this one. What's this one say? Yeah, I'll
specifically Homo sapiens, not genus Homo, but Homo sapiens.
So that's why I asked you in the beginning, do you believe that they're absolutely separate species or a subspecies? So I've got a lot of paleo experts that say, hey, listen, they're Homo sapiens, subspecies Homo neanderthalensis. So those are the two competing views. So they're at least putting it as a kind of like Canis domesticus. You've got all your different dog breeds, from my understanding, would be considered a subspecies, but still all a dog. So is it a separate species or is it a subspecies? Now, the papers that I have suggest they're a subspecies.
Which would indicate common ancestry, right? That's the common ancestry within the species. If you look at dogs as Canis lupus familiaris and wolves as Canis lupus, they have a Canis lupus common ancestor. So if it's Homo sapiens neanderthalensis, then that implies a Homo sapiens common ancestor.
Do you believe that they're separate species or a subspecies?
They're separate species. They're not a subspecies.
Okay, well, there you go.
They share a common ancestor that was Homo sapiens.
Those are the two views that I'm talking about, and the
genetics support one and not the other.
Because I'm saying that they're a human variant,
right,
which in a way, I guess, could be they're still the same species.
Well, human meaning Homo sapiens or human meaning genus Homo? Those are two different things.
They're Homo sapiens.
Okay, so that's...
Well, the genus Homo would also consist of Homo habilis, Homo erectus, Homo... I mean, yeah, but most of the genus Homo, I would say, are variants of the Homo species.
paleontologists who are then saying they're Homo sapiens neanderthalensis, are they, now again, fossils, I'm not familiar with that literature, but are they claiming then that the common ancestor of us and them would be Homo sapiens? Or are they treating Homo sapiens as a polyphyletic group? I think it's the latter.
So, for example, this article here that is derived from an actual paper, typically, you get the articles about it, says, were Neanderthals a separate species? Your claim is they were. So it says, our genes suggest that modern humans interbred with Neanderthals, and that's led some anthropologists, and this is a secular article, to claim Homo neanderthalensis should be considered a subspecies of Homo sapiens rather than a separate species. That's my only question is, do you agree if they're separate, or do you think they're a subspecies? That's all that matters.
No, and the answer is no, because what matters is not interbreeding. What matters is common ancestry.
Right, and my point is, there's ones that would agree with you. Those would be your your splitters, and there's ones that disagree with you. So you'll have to take that up with them.
Because I think you're conflating two things. I don't think you have a paper, and correct me if I'm wrong, but I don't think you have a paper that says that Neanderthals should be Homo sapiens neanderthalensis because they share a Homo sapiens common ancestor with extant Homo sapiens.
That's
I don't think you
irrelevant.
have a paper that says that.
It's irrelevant because the ones that say
that's
they're
the whole debate standing.
No. Obviously, all these paleo experts still have their underlying assumption that human evolution is true.
Oh,
the ones that agree,
real quick,
it's my question, so I get the last word. The ones that agree that they're a subspecies, Homo neanderthal or Homo sapiens subspecies Homo neanderthalensis, are agreeing, in maybe in a roundabout way, that they're just a variant of a human, and that's our position, that they're a variant of a human. Obviously, they're not just saying, "Oh, human evolution isn't true," but they're not saying that they're a separate species like you are saying. That's the whole point.
Okay.
Next up, I don't think this guy might have been paying attention for the entire thing, but sorry. Zune 153 for SFT. Why do modern humans not have a Neanderthal Y chromosome? I think
good question. That'd probably be a big discussion. I mean, the fragmented bits we get anyways with the Neanderthals, I mean, usually how many nucleotides do we typically get? Not very many. Hey, Dan, I know you can help me out with that, but typically they're small and the Y chromosome is just too large. I think we might need more.
Sorry, I was going through the comments to just say that we're going to cut off the questions here. So could you just repeat that question real fast? Sorry.
For Standing for Truth, why do
no. The question that Standing asked about the size or something. I'm sorry, I missed it while I was writing in the chat.
Yeah, the sequences, from my understanding, and correct me if I'm wrong, that they get from the Neanderthal fossils, the DNA, they're oftentimes very fragmented, just like a few, maybe 10, 20 nucleotides long. Like there's not a whole lot. Like I think they need to find a little bit more. Yeah, go ahead, Dan.
They're longer than that. I have a paper on that handy, specifically about the reliability of those genomes, and I didn't need to bust it out because we agree that they're perfectly reliable. But it's about shotgun sequencing and how that technique works, but I don't recall the length off the top of my head. My impression is that the fragments that are present are quite long, but when you do modern like next-gen sequencing, you do very short sequencing reads with very high coverage. So you may only be sequencing 20 or 50 nucleotides at a time. Right. But that's different from saying that the DNA present is only 20 or 50 nucleotides long, right?
Right.
It's those are two different questions.
And from my understanding, like I know Dr. Todd Wood, he'll point out the fact that we can typically differentiate chemical damage and contamination by focusing on the ends of the DNA samples that typically are consistent across, since we're talking about the Neanderthals, consistent across the Neanderthal samples we have. So.
Sorry, I confused people in the chat. What I meant is we're gonna say no more new questions on the list. We only have a couple left, but no adding to the list. That's what I meant. Sorry, I didn't mean to confuse everybody there. Sorry about that, everybody. There's I think there's like 3 left. There's not that many. So that's
all right. There's
sorry.
3 left.
Yeah, there you go. So we'll do these real quick and then
we're good. Zoom 153 for us standing. What scientific paper supports the idea that mutations decrease genetic diversity even if they are deleterious?
So what scientific papers confirm my claim that deleterious mutations decrease genetic information?
Genetic diversity, not information, diversity.
I don't have any at the top of my head. I'll cite some afterwards.
All right.
We have next here.
This was Covert Cuttlefish for Standing Again. Why did you publish on Amazon instead of an academic journal?
You can just Google, good reasons to publish on Amazon, and then look at the pros and the cons. But it's kind of, I don't have a PhD, so I don't think I could publish an academic journal. I think that's just kind of a dishonest question to make. I can have good points all I want.
You don't need a PhD to publish. My only 2 peer-reviewed papers were pre-degree. I didn't even have a master's, and I published with undergraduates that didn't even have a bachelor's. You don't need a degree to publish.
Well, we've got lots of published articles published papers from PhDs such as Dr. John Sanford, Dr. Robert Carter, Dr. Tompkins. I mean, Dr. Tompkins ran a genomics research center for years and years. So if you want some papers,
but they're not in the literature. Publishing as a PhD and publishing in the peer-reviewed literature are 2 different things.
Yeah, they do. They do.
Well, they do, but they don't publish their creationist stuff in there.
Well, they would publish papers where the data in the paper itself would corroborate a creationist position, but they don't come right out and say, hey, this proves young earth creation, or then they probably wouldn't get published, because in the peer-reviewed process, you can't question the actual overarching evolutionary theory. You can question little bits and pieces of it, of course, but the actual worldview and the paradigm itself, you can't question. You're not going to be published, of course.
In my experience, I disagree, but okay. I mean, there are controversies that literally end in fistfights at conferences. People are not opposed to publishing controversial things. That's what gets clicks and stuff, and everyone loves doing that. But yeah.
Well, I guess so. Christopher Bear says the question was why SFT didn't publish. Yeah, but maybe I will in the future. We'll see.
Go for it.
Next step.
You absolutely should.
Last question from Zune153 for Standing. Why does sub-Saharan African populations have little to none Neanderthal DNA?
Well, according to the evolutionist claim, I think it would also corroborate ours, because I'm getting a little tired here. Let me see if I can remember how it goes. So your Erectus would have left, subgroups of Erectus would have left Africa, while other Erectus would have evolved independently in Africa and outside of Africa, say in Eurasia, in Europe. They would have evolved independently into Neanderthals, and the ones that evolved into modern Homo sapiens in Africa would not have had any communication or interbreeding or anything with the Neanderthals that evolved independently outside of Africa. Is that more or less kind of how the story goes? So I don't see why.
It's because Neanderthals evolved from Homo erectus outside of Africa and never migrated back in. So the Homo sapiens populations that never left Africa never directly encountered the Neanderthals to interbreed with them. Now there was a paper literally published this past week. It's so cool that there is actually a little bit of Neanderthal DNA in some African populations, but it's due to interbreeding between European and African populations and Middle Eastern African populations. So it's not direct interbreeding, it's integration via those other Homo sapiens populations.
Dr. Dan's right about that. Yeah, I've heard, I've read some fascinating stuff on that, but the same reason why you would, other than that paper that suggests a little and the reasoning behind it, would be the same reasoning for our model. The fact that the Homo neanderthalensis, the people group that evolved and adapted into them, would have been a breakaway population, probably pre-Babel, maybe post-Babel, but they wouldn't have had the interactions with the African people group. So the same explanation as the out of Africa scenario. Good question, though.
That's not the same explanation, but okay. I think that was the last question, yeah?
Yes, that was.
All right. So I think we're done, everybody. So Dakota, thank you so much for doing the timekeeping and the question curating. Standing, thank you a ton for being here. I really appreciate it. This was super fun, and I would love to do this again if you're open to it. But I would ask that you do your homework a little bit more first. Any final words from?
Yeah, and, I'd love to do another conversation as well, as long as you do your homework first too.
I literally do this for a living, but thank you. All right, so I'm going to end the broadcast and then awkwardly wait here while I forget that it takes 2 clicks. Thanks, everybody. Have a good night.
Thank you.